Welcome to this explainer. Today, we're going to demystify something that completely changes how you look at math. We are mastering the fundamentals of HCF and LCM. Now I know, if you've ever felt intimidated by those acronyms, honestly, don't worry about it. Because by the end of our time together, you're going to see exactly how numbers interact, connect, and share with one another. Let's dive right in.
Think about it for a second. Have you ever wondered how numbers actually find common ground? When we talk about math, we usually just think about adding things up or taking them away, right? But numbers actually have this whole hidden life. They have pieces that build them up and paths that stretch out in front of them. So today, we're going to look at the secret building blocks numbers use to share space and find alignment with each other.
Here's our roadmap for today. First, decoding factors. Second, understanding multiples. Third, the highest common factor. Fourth, the least common multiple. And finally, a quick cheat code and some practice.
All right, Section 1, Decoding Factors.
Let's start with our very first building block. A factor is a number that divides another number exactly with no remainder. And I really want you to heavily emphasize those two phrases in your mind, exactly and no remainder. Because if you try to divide a number and you have little leftover pieces flying around, well, you haven't found a factor. Factors are clean, perfect cuts. They're literally the exact whole ingredients that make up a larger number.
Let's look at the number 12 as an example. If we want to find its factors, we just look for the multiplication pairs that give us exactly 12. So we have 1 times 12, we've got 2 times 6, and we have 3 times 4. Now, if we try 5, it just doesn't work. There's a remainder. So we gather up all those numbers we just used, and we get our complete list of factors for 12. 1, 2, 3, 4, 6, and 12. It's like a giant puzzle, and these are the exact pieces that build the number 12.
Moving right along to Section 2, Understanding Multiples.
Now that we know about the pieces that build a number up from the inside, let's go ahead and shift gears. A multiple is the result we get when we multiply our starting number by 1, 2, 3, 4, and so on, infinitely. So if factors are the ingredients inside a number, multiples are kind of like a character's footprints stretching forward into the future. It's the number taking a step, then another step, then another step, growing by its own exact size every single time.
Let's look at the footprints of the number 5. The multiples of 5 are 5, 10, 15, 20, 25, 30, 35, and it just keeps going. Notice that energetic rhythm there? It's really just skip counting. Every time we multiply 5 by the next whole number, we're stepping perfectly along its path of multiples.
Which brings us to Section 3, Highest Common Factor.
So what actually happens when two numbers need to share their pieces? Well, finding the HCF follows a super simple, repeatable three-step logic. Step 1, list all the factors for both numbers. Step 2, scan those lists and find the common factors, meaning the numbers that show up in both lists. And Step 3, out of those shared numbers, you simply pick the highest one. See, it really is that straightforward.
Let's try it out and find the HCF of 12 and 18. First, we list the factors of 12, which we already figured out. 1, 2, 3, 4, 6, and 12. Next, we list the factors of 18. 1, 2, 3, 6, 9, and 18. Now look closely at the overlap here. What do they actually share? Well, they both have a 1, a 2, a 3, and a 6. And there you go, those are our common factors. But we don't just want any shared factor, right? We want the absolute largest puzzle piece they have in common. And out of 1, 2, 3, and 6, the clear winner is 6. 6 is the highest common factor. It's the largest single number that divides perfectly into both 12 and 18, with absolutely zero remainder.
All right, on to Section 4, Least Common Multiple.
Okay, we've totally mastered sharing factors, so let's apply that exact same concept to our footprints. Just like before, we have a parallel three-step method to keep things super consistent. Step 1, list the multiples for each number, stretching them out into the future. Step 2, spot the common multiples where those numbers step on the exact same spot. And Step 3, pick the smallest or least common multiple. Basically, we want the very first place their footprints align.
Let's find the LCM of 4 and 6 together. First, we list the multiples of 4. 4, 8, 12, 16, 20. Next up, the multiples of 6. 6, 12, 18, 24. Now we're scanning both sets from left to right, just searching for that magical moment where the numbers match up.
And there it is, 12. 12 is our least common multiple.
Now, sure, if we kept counting, 4 and 6 would eventually match up again, right? Like at 24 and 36 and so on. But we aren't looking for the largest. In fact, multiples go on literally forever, so there is no largest. We're looking for the very first, smallest step they share. And for sure, that is 12.
Let's wrap things up with Section 5, cheat code and practice.
Okay, so you've got the fundamental logic down, but I want to share a little insider secret with you, just to really lock it in. If you ever get confused, HCF means you're looking for factors, and you want the biggest one. LCM means you're looking at multiples, and you want the smallest one. HCF is the biggest piece inside, LCM is the smallest step forward. Lock that contrast into your memory right now. It's a real game changer.
All right, it is officially time to practice. Grabbing a pencil and actively solving is how we turn this explainer from just simple information into actual mastery. So we're going to run through 4 quick challenges. And hey, definitely feel free to pause as we go to test your brand new skills.
Challenge number 1. Find the HCF of 8 and 12. Remember your steps here. List the factors of 8. List the factors of 12. Find exactly where they overlap and just pick the biggest one. Take a second to solve it.
Moving to challenge number 2. Find the LCM of 3 and 5. We're switching gears here. You're looking for footprints now. Count by 3s, count by 5s, and spot the very first number that appears in both of those lists.
Let's keep that rapid-fire momentum going. Challenge number 3. Find the HCF of 15 and 25. Go back inside the numbers. What are the pieces that make up 15? What makes up 25? And what is the absolute largest exact piece they share?
And finally, challenge number 4. Find the LCM of 4 and 8. Think about your cheat code if you get stuck. Least common multiple, the smallest footprint they share. Write out those multiples and find that very first alignment.
Well, if you took the time to work through those, you've officially locked down the building blocks of highest common factors and least common multiples. You now know how to look at numbers not just as isolated digits, but as deeply connected patterns. So, I want you to look around you today, because math is really just a language of connections. What other patterns are hiding in plain sight in your world? Keep stepping forward, and I'll catch you in the next explainer.